different types of structures have different advantages and disadvantages. Timber is no different in that sense. There are certainly areas of mass timber that require more consideration early in design. So it's important to take a look at things like, direct sound transmission, choosing your assemblies to, address sound and airborne sound and impact sound coming straight through, but also looking at indirect sound transmission. And that's also called flanking sound transmission. That's something that's really important in mass timber. A lot of people, and this is especially the case when developers are relying on architects to provide that acoustics knowledge. A lot of people think only of direct sound transmission. They think, I have a suite beside a suite or above a suite, my wall, what's my floor ceiling assembly? Is that, what are the ratings? What are the SDC and IIC ratings for airborne and impact sound? Is that, are we meeting our targets, and is that it? That is a great place to start, but the next step after that is, okay, well, what are my indirect sound transmission paths? What's going through the ceiling, through the floor, through the exterior wall, through the corridor wall? I mean, there's a ton of different indirect paths that can certainly result in, when you're in the field, when you have somebody standing on one side and standing on the other side, you can hear conversations, you can hear a lot of sound because somebody hasn't thought of that indirect sound. So really when thinking of mass timber, specifically, I think that, taking a look at those indirect sound transmission paths, making sure that you're addressing the sound going through the ceiling, making sure that you have something, usually a lot of mass timber buildings include some type of topping. So making sure that topping, whether it's dry or wet topping, is interrupted at demising walls. That's important for limiting sound going through the floor. So, these types of considerations for indirect transmission is really important with any lightweight structure, including wood frame, but this is also the case in mass timber. But some of the benefits of mass timber acoustically, in some sense, the modular ability of it. So coming back to that elevator vibration example with poured concrete, you have the opportunity to isolate mass timber panels from each other, which is something you can't do in a poured concrete building. And so that really provides you that extra stage of isolation, whether it's pipe isolation or conduit isolation, equipment isolation, flexibility of designing the mass timber building with isolated the vibration or reduce the amount of vibration traveling through those joints and through the structure. That's something that you can't get out of a poured concrete building. So certainly there are advantages and disadvantages, but those are just some of the kind of early things to wrap your head around when exploring mass timber from an acoustics perspective.